Hi, everybody. I'm Grace Stern. I'm Virginia's State Extension Master Gardener Program Coordinator, and I'm here with Dr. Alejandro Del-Pozo, who's going to give us an update on the invasive box tree moth in Virginia. Go ahead, Alejandro, introduce yourself and go ahead, start your presentation.
All right, sounds good. Very good morning, everybody. Thanks for joining us today. Happy New Year. It's 2026. We got new and exciting things to do. And it's not the top of the morning, but it's still the morning. So I'm really excited that you guys are interested. And this is something. It's a creature that we really don't want it to be here, but unfortunately, it's here in Virginia and several states. You're going to learn about it. So during this presentation, I'm going to walk you through what a really nice collaboration between United States Department of Agriculture and APHIS and PPQ and Virginia Tech has done so far for this invasive. We want to walk through all of that. I'm going to touch about what, the quarantine and I didn't include how to report, but we will talk about that at the end as well. But you basically going to hear about the research and the information about this specific creature. Without that, my name is again, thank you, Grace and Ed, for inviting me. I'm Alejandro Del-Pozo. I'm a entomologist, but I'm located in the Hampton Roads Research Extension Center in the beautiful Virginia Beach. So some of you might know me directly, some of you maybe not. It's our first time, so I'm happy to be acquainted to you. And at the end, you're gonna have my email. Please, I would like to let you know that it would take me some hours to get back to you, but if I can be of any help, just shoot me an email and I will be able to point it to you to the right direction and give you some information. So we appreciate you. Master Gardeners are the face, the heart, and everything for corporate extension. So we're so happy and glad and honored that you guys join us. You guys represent us. So the more information you provided to you, the better everybody in the community was going to be in for. So with that, let me share my screen, which is gonna, here we go. That's presentation right there. Okay. All right. So I titled this presentation as an update. And as I previously mentioned to you, you're going to hear about all the research that Virginia Tech, in collaboration with United States Department, so USDA, APHIS, PPQ. So I got to give a shout out to the collaborators here: David Rivera, Jason Bielski, Julie Brindley, Ignacio Baez, and Greg Simmons. They're both from the USDA, APHIS, PPQ. With that, I always like to acknowledge first, from out of the gate, acknowledge all the support. This took a village to learn about this invasive. So there was the Lockport team at APHIS PPQ, the Salinas in California, so Lockport in New York, Salinas, California, the APHIS PPQ team. They were phenomenal. APHIS PPQ took the lead on several of these projects, and we were able to have a great collaboration with them as well. The entire team here at the Hampton Roads Research Station, they step up. You're gonna learn about it. So we needed to go to New York once a week, believe it or not, to study this insect and learn about it. So now we're very much well equipped to know what's coming and how to handle that part. So and you hear about it pretty soon. The American Hort Association was instrumental to support us, connecting us with growers, and all the growers stepped up to, giving us boxwood plans, support, ideas. We have conversation, discussions, and everything in between was actually, the industry was really cohesive in order to learn and understand this invasive and be prepared when came in. All right, so today we're going to learn about box tree moth. Box tree moth, it's now in Virginia. But back then, in 2021, 2022, this is what it looks like in Western New York. So you have on your left a beautiful boxwood. That's July 11th. The same boxwood, 14 days later, you can see it on the right. a picture summarizes more than 1,000 words. So I want you to have a feeling about the potential, the damage potential that this invasive can represent for boxwoods. And we love boxwood. Boxwoods are the most beloved evergreen that we have. It's $140 million industry. It's really healthy. You know, we have boxwood blight and now box tree moth. Is this the, people will ask me, is this the end of boxwood? The answer is no. We have research and support and collaboration that makes the boxwood industry healthier and stronger. So we're coming back like a phoenix from the ashes and build ourselves again. So I don't think we're gonna see. And why do we love boxwood? Whether there's cultural references, it's on the hedgerows, and it is an evergreen. And man, New Yorkers in Western New York, they love the boxwood because that's the only thing that's gonna be green when there is feet and feeders now. So, and then all of you might have your own and specific reasons why you like boxwoods. And those are valid as well, right? So boxwoods are very beloved, and we're concerned about what could damage them. And box tree moth is one of the culprits that get us awake at night thinking about how bad things could go with the boxwood. So box tree moth, the scientific name Pseudolima perspectalis, it's a lepidopteran, so it's a caterpillar in the immature stage. So it's native from East Asia and moved to Europe in the 2000s. First reported in Germany in 2006, 5 and 6. And then demolished, attacked, heavily infested Europe, throughout Europe, and then move across the ocean, came to North America back in 2018. First reported in Toronto, Canada. And then what happened after that? This caterpillar started moving, right? Because they can fly, the commerce, the trade, you know. It is reported in literature they go up to multiple generations, and the native range can go up to 5 generations in a year. It's expected to be 2 or 3, you know, as averages, and they overwinter as the immature. So here in the pictures, those are where, let's see if I can get that pointer. Yeah, I have a pointer here. So where the pointer is, this is an egg mass. When you flip the underside of the boxwood leaf, I dare you, if you find these things. But you could, and that's an egg mass over here for box tree moth. Then you got, then these guys will hatch. You got the neonates and small caterpillars, what are the early instars, and then you have this starting defoliation. Here is a very well-developed caterpillar, have the stripes. So this is very key to understand. This the background is kind of like greenish, yellowish, right? And it have stripes, dark stripes going along the body. So here is along the body, you have yellow, light yellow, and dark lines going across along the body. There's hairs, and then there's a very darkened head capsule. So the head is very dark, right? And that's the caterpillar. And then from caterpillar, you go to pupae, and that is going to be within the boxwood canopy. And then the pupae gives you this beautiful, big, beautiful moth that it's going to, you know, mate and then move, disperse and move around and have this darkened borders around the wings, and there's 2 specks, right? Here's 1 and here's 2 specks on the foreside of the wings, so like the right there in this part. And they're slender, they're very charismatic, but don't be confused. These are the box tree moth adults that are going to be laying those eggs and continuing with the cycle. So it's very important that all of us recognize these caterpillars and these adults flying around and moving around or present during the defoliation of the boxwoods. Some of the shots that we have from our trips to New York, you have the caterpillars. Look at a little bit of the webbing, and then there is all this window painting. That's what we call it. They start munching around that. Some of those caterpillars will spin the web and protect themselves. So look at this, how, one caterpillar can start, eating from left to right and being protected by the two leaves. And now you got more of the caterpillars being kind of hidden when they're bigger. So they move from the top of the canopy to the center of the canopy, and they start moving throughout the canopy to actually get to the healthy leaves of the boxwoods. But this won't stop here. And I tell Joshua, my son, and Emma, my daughter, that the true berry hungry caterpillar exists, and it's called the box tree moth. So you have defoliation, and the berry hungry caterpillar box tree moth won't stop there. He will go and peel the bark, eat the bark, feed on the cambium. So this is a caterpillar right here. And look, this is a beautiful shot from Lynn Batrobe. Lynn it's a retired USDA scientist who oversee the collection of boxwoods. So he retired, but he is a boxwood expert. Lynn come with us, train us, educate us about boxwoods. And he took this beautiful picture of, look at this caterpillar is feeding through the cambium. Can you wonder what is going to happen next? So you have the complete defoliation. And then the cambium of the plant, it's also eaten up because the hundreds of caterpillars destroy boxwoods. This is what you're going to see. You're going to see hedgerows completely gone, memorial gardens completely gone. And most of people will say, you know what, I'm done. These things they're going to die. And the idea is that we don't want to get to this point where we, the community, start cutting and putting in the curb for the city to pick them up. And this is very sad. This is one. Yeah, I don't want to getting down into the feelings of, oh, we're doomed. No, the idea is that we want to prevent this. We don't want to get to this point where a boxwood that took you so many years to grow could be lost within 1 or 2 seasons of heavy defoliation because of the box tree. The more informed we are, the better we can react and establish an IPM program for this pest. So where is box tree moth in the United States? Started in New York in 2021, then moved to Michigan in 2022, and then in Ohio, Massachusetts in 2023. Then jumped to Delaware and Pennsylvania in 2024. And West Virginia, Maryland, and Virginia are the latest one that joined the club during 2025. Now, Virginia last year announced the establishment of a quarantine. And this week, West Virginia, the quarantine for Virginia is only for 3 specific locations. And for West Virginia, this week was announced for the entire state. Quarantine means that you have to have inspections. The movement of goods in this is goods of boxwoods are restricted across county lines or across the quarantine lines. And if you're going to move it, you need a permit, you need to comply, and you need to control potential presence of this invasive, in this case, box tree moth, in order to avoid the additional movement of this pest outside the quarantine. So this is a legal control tactic that is run by our Department of Agriculture, and it is the goal to prevent the further spread of this invasive in other areas. And that's the idea. Whoever is in the quarantine, in this case, Winchester, Loudoun County, and I'm missing one more, but there's 3 areas. They are expected to be, checking plans, comply with the suggested treatments before moving boxwoods around and outside the quarantine. And if you want to learn more about it, I invite you to look up with VDAG. VDAG has a nice information about the quarantine that has been established in Virginia, and please follow that up. just to get ahead of myself, BDAG also is the one that we are going to report sites. So if you believe that you have box tree moth, one, your county agent can definitely help you, but the idea is to report this presence, potential presence to be confirmed by VDAG, and there is a form, and all of that I can share that late at the end with Grace, and we can distribute that. But there is a specific form that you need to fill out in order to report the presence of box tree moth in your area. Right now is in Northern Virginia, and the idea with the quarantine is that we're gonna slow the spread and try to contain that spread as much as we can. All right, so 2021, the box tree moth is coming. Jump to New York, and we want to confirm the phenology, the biology, the ecology of these insects to be prepared. And fast forward, now we have all this information that we share with every stakeholder. You guys are stakeholders, the growers are stakeholders, everyone who is interested and learn more about box tree moth. This is what we share with them. So we run a set of traps. You can see those. So there is a pheromone, that's the perfume that the males would follow in order to find mating female. So the trap mimics, in this case, this is the trap, mimics a female. It's green because we want to reduce the bycatch in the trap. And the pheromone goes in this little container. And here we have a yellow sticky cards that we also use, and I'm going to talk about it a little bit more. It's a passive way to collect insects moving around the boxwood. So we wanted to know if there is beneficials coming in and out and moving around. And this is a temperature humidity logger that was also set in some of the traps because we were interested, and I'm going to talk about this too, about growing degree days and how is there is a predicted way to tune in the timing of box tree moth in our area, and we're getting close to that. Now that is how we monitor for adults, and then for immatures we did it 25 centimeters by 25 centimeters squares, multiple squares within the boxwoods in order to do a visual scout and count for caterpillars, eggs, and pupae as well. We went to New York. We have up to 20 traps in Niagara County, Western New York, beautiful Niagara County. And then we went there weekly to count and follow the population of box tree. So what we learned is that there is two peaks of activity. The top are adults, middle graph is the small caterpillars, so 1 to 3rd, and then you have the large caterpillars, which are 4th, 5th, sometimes 6th. The different colors are the different years that we did. So I have 22 and 23 here. So the first peak of activity for adults is in sometime in July. And then there's another one in September. And as a textbook, you have the caterpillars following that, some weeks after that. And then there is a bunch of early caterpillars because as I mentioned, these guys will be the ones that are going to overwinter into the next year because they overwinter as immatures. Now for the large caterpillars, you got one peak of the infield population that gets in there, and then the second peak continues. We're missing some sort of the if you notice, here's June, but during the spring, these caterpillars will get activated, and then we're going to complete their cycle, and then this is where these adults are coming from. So some sort of like a broken cycle where immatures are overwinter, and then 1 year you're gonna have activity, and the following year you have the remaining activity for this insect. Now, when we compare 2023 to 2024, because we did this for 3 years, the 2024 shifted a little bit. So if you see, there is a little bit of shipment. So there is a possibility, depending on the temperatures, that this insect will tune into how temperatures are going to mediate their development. But long story short, there is 2 peaks of activity, regardless of where exactly temperature it's gonna be. Now the question is, are we gonna have 2 generations in Virginia? Is this what happened here? God forbid that gets in Virginia Beach. Are we gonna have 3 generations? Because the potential is to have up to 5 generations. So those questions still remain unanswered. But we know so far that the expectation is we're gonna have 2 waves of activity, at least 2 waves of activity for box tree moth in Northern Virginia and anywhere there. Now going south, how this instance is gonna behave, it still again remains to be seen. Now we did some sort of defoliation rates as well. Overall, if you do nothing, it will go in the teens. So if you picture 15, 70%, close to one fifth of the canopy of your box was going to be removed, no matter what, if you do nothing about it. All the way to in August, when you have all this peak of activity and then you are accumulating damage, you can go to 1/3 of the canopy being gone on average. But if you see in some instances, 100% of the canopy can be gone depending on how many caterpillars are being deposited in place by females flying around, right? So something to keep in mind is that defoliation is going to be a result of caterpillar activity, and it will take some time for us to see, this heavy defoliation, unless you have a large population of caterpillars, that then you're going to be able to see very rapidly when there is defoliation, active defoliation in the boxwood canopy. Now, you remember those temperature data loggers that we use. We collected that data every hour, and then we construct a growing degree day, which basically trying to explain how much heat units the insect needs to accumulate in order to develop and move from one phase to the other, right? That's kind of like the idea. And what happened is we study this insect, we know what the temperatures are going to do, so we are able to build this growing degree day model in order to predict when larvae or when adults are going to be showed up. And that's the idea. The idea is that if we have some sort of prediction, can we be proactively looking and trying to find hotspots in the landscape, in nursery, that you will be able to detect and do some action about that. Just an example, because we have up to 8 different sites that we built and calculated and actually, add the growing degree day. So the growing degree day is this line that goes all the way to 1,800 growing degree days in accumulation. Some years took a little bit less, but overall, and this is our data plotted, right? Our data plotted into having those growing degree days curves as well. So we were able to document that somewhere between 600 growing degree days, and this is there is a base temperature, and we use 10 Celsius. Now we can, I'm gonna getting ahead of myself, but with 10 Celsius, because this is the literature that comes from Asia and Europe, tell us that 10 Celsius is very important temperature. That's what, close to 50 Fahrenheit. And that's a really important temperature for development in the immature stage of box tree moth. So we use that, we build that growing degree days, and we notice that, for example, adults, in this case is adults, peak between 600 and 700 growing degree days at base 10 Celsius. And then the second peak, it's at the 1400 growing degree. So this is really important, because if we're running growing degree days, and some of you might be familiar with that, for trees and all these different things, now having that tool will help us to be proactive, as I mentioned before. So when we did all the 8 to 9 different locations, we were able to put it in summary. That's the table you see, that adults, the first appearance that we have based on our data is in the 500 growing degree days. And then the first peak, as I mentioned, is 600, 700. Larvae, it's a little bit later, because that's what, if you remember that graph that I showed you with the bars, the adults come first, and then the caterpillars come later after that. And then the second peak of adults, it's in the 1400, right? And then something there for the early instar caterpillars as well. So what is pending is we're going to use now our 2024 data to validate these calculations, and we're going to change some of those. We're going to do a 50 Fahrenheit growing degree day and see if there is any documentation of correlations with that. But we're also going to use a different temperature to see if lower temperatures can influence when this insect is going to show up in the system. So stay tuned. Now we have phenology. So we know there's two peaks. We know that there is a potential to be predicted with the growing degree days, and there is existing beneficials. So there are already existing beneficials. There might be preying and attacking box tree. Box tree moth is the new kid on the block, but then there are predators and parasitoids around our landscape that will be able to see box tree moth as a new prey. So what happened is we were able to collect some damaged pupae. You can see in the bottom. And from some of those pupae, we actually rear out an ichneum monet. Here you can see from the picture, those are the pupae that were inside the containers. We send it for USDA for identification. This Pimpla disparis is a spongy moth parasitoid that was heavily released in northern latitudes for biological control. Now it's shifted. Well, first got established naturally because no one are releasing in Niagara County right now. But then that one got established and was able to transition to find box tree moths as a potential prey. Unfortunately, we only found this 1 year. So it seems that it is still inconsistent for Pimpla disparis, so this parasitoid, to use box tree moths as a prey. So what happened is we employed the yellow sticky cards as you show in the very first picture that you saw in the very first picture I showed you for the phenology. And then what happened is it's a passive way to see what insects are around that area. And then we have spiders, lacewings, ladybugs, some parasitoids, and we created some sort of like a clumped group. We call them predators. So lacewing, hoverflies, ladybugs, and big eye bugs were all add together as a variable to say that what the predators are doing when there is a presence of caterpillars. And we believe that they are still naive. So this regression shows that doesn't matter what density of caterpillars for box tree moth were present, the yellow sticky cards are also different numbers of predators, the lacewings and the hoverflies and the big eye bugs and all this that were clumped together, so that's what predators, this is the x-axis. And then the y-axis were the caterpillars that we collected. When we have those locations and we run those regressions, there is a flat line, meaning that there is no relationship that we can look, even though correlation doesn't mean causation. At least we want to see if there is a proxy where we say there is a lot of caterpillars, there is a lot of beneficials, right? Unlike when you analyze the other pests, and this is what the textbook will tell us. If there is a lot of pests, there will be a lot of beneficials. So this is a beautiful textbook example. I use this for some of the classes I teach as well, where you have predators and you have other pests. On those sticky cards, those are plant hoppers, psyllids, plant bugs, and other things. And you see this beautiful relationship when there is more prey, more beneficial. So the beneficials out there doing their job, they're not using box tree moth yet as a common prey. It's Mother Nature's gonna catch up. Box tree moth is the new kid on the block, very understandable. We're gonna follow that pattern. Hopefully, sometime in the next seasons, the beneficials will be able to exploit box tree moth as a new prey. Now, another big project that we did with USDA APHIS PPQ is an area-wide suppression in urban landscapes using mating disruption, the pheromone, and using Bacillus thuringiensis, the very specific Lepidopteran insecticide, Bacillus, and those were applications. Then we knew when the caterpillars were done. Just to give you a brief summary, mating disruption is when usually the male will find the female. The female is emitting this perfume that I told you about, and the male will follow that trail and find the female and then mate, and then the mated female will lay the eggs. So now when you have mating disruption, we put dispensers with the pheromone. They are emitting this perfume and then confuse the male. So then the male will not be able to find the female. So female, it's not mated. It will not have the caterpillars, and technically overall the population will get lower. How do you measure? What will be the proxy of the success? We put a pheromone trap in here, and then when we have 0 males or no males, that means that the males got confused because they cannot find that pheromone trap. So it's called the shutdown of the monitoring trap in order to understand that the mating disruption overall, it's actually working. This was a Herculean effort, and we are so thankful for people like you, the community members. We rally in the trooper to help us. So we went to one specific town, well, actually 3 towns in Niagara County. And here I want to call your attention. So in 2023, we actually knocked 220 doors to ask homeowners to let us place these pheromone dispensers in their backyards or front lawns. And then we did 225 in 2024. So we did it 2 years. Some of them will remember us in 2024. Oh, you're the guys for the box stream. Oh, yeah, come on over. Some of them say, well, no, I'm not really interested. You know, you have both. So here's, we have all the way to 60% participation rate, which is amazing. The community stood up and say, we're going to support you. 60%, it was a great success. We were able to deploy this. So if you picture, and let me show you this. Here is one of the towns, and every single house that it's in green were the ones that say, yeah, let's go ahead and place the dispensers. By the way, they're safe. They were placed 5 or 6 feet above the ground to avoid, children or pets will be, in direct contact with the pheromones, but which they're not toxic. They just have this perfume for the moth. They're really specific, but still we want to have them protected. Everyone had them protected. We were the ones managing and dealing with those dispensers. So here and we did this in 3 locations, right? So this is one of the main locations. And the green ones were the ones that say yes, the red said no, the maybes were the yellow, and then some of them where we couldn't find a person to talk to, so those are the blue. So in this case, this is Lewiston, New York, and the beautiful Niagara County, and then we have all these maps for all the areas we use for the 2 years that we run this experiment. So it was a demonstration plot. Here on the right, you can see the dispensers. We have to use these long poles to clip those dispensers. So here is the solid membrane that it's impregnated with that pheromone. It's the chemicals, right, that we use. And they're going to get released over time. And then the wind is going to move that chemical and then disperse that, as you see in that diagram that I show you with the tree at the beginning, right? And then we clip them, we put it in different areas, we calculate it, we disperse those. And so we actually have control areas outside, and then the treated areas where we put the monitoring traps in the middle of the plot. And then we did this every month where we have to scout for immatures as well. And once the immatures were detected, we spray the BTK, so the Bacillus thuringiensis. So this is a 2-treatment experiment. So where we place the mating disruption, the pheromones dispensers, and then we targeted the presence of caterpillars when detected. Some of the results were, so here you see control. So we did nothing in there. And you can see how these are adults in the monitoring trap for the 2 years. And you can see where we put the mating disruption and the Bacillus thuringiensis Kurstaki. It's a flat line right there. Sometimes we can capture things, but it mostly was fat 0. Look at this one. Then we have some captures. But overall, we have this clear separation about the moth being present in the control areas that had nothing, and then the treated areas being almost 0. And then box tree moth per trap, those are the averages. You always have a higher trap captures in the controls compared to the what we call area-wide treatment. In this case, mating disruption plus Bacillus thuringiensis. Now with the immatures, we were able to see that there were differences at the end of the season. At the beginning of the season, when we start scouting, there was an already established population, so we expect to see that there was no difference. But then when we deploy the treatments and we were targeting the immatures and we have the main disruption in place, we were able to see this clear separation of the higher caterpillar numbers per boxwood in the control areas where no treatment was done, and then the area-wide suppression effort had the lower number of caterpillars in both years as well. This is very exciting because this tells us that this entire system, using mating disruption and the use of Bacillus thuringiensis, in this case a very specific insecticide, can help managing box tree moth in large areas. Well, plant damage kind of similar. If you have remnants of plant damage, that could skew the data, but still we saw some differences. When you are in the controls, you're expected to have a little bit and slightly higher damage compared to the ones that inherit the damage from previous seasons, and there were some caterpillars in there as well in the area-wide suppression, mating disruption, and Bacillus thuringiensis plots. So I'm giving you a glance. I call them the executive summary of things. So we did phenology, we did growing degree days, we understand the existing natural enemies, then we use mating disruption, the pheromone, and the very selective insecticide. And now we're going to close the circle to see how other chemicals can help us control this caterpillar. So IR4, which is meant to serve the commodities, the very specific commodities for and specialty crops to get new active ingredients being tested. IR4 led the very first essays for laboratories treating using different chemicals and having box tree moths exposed and do mortality. Then USDA APHIS PPQ did both laboratory, a little bit of field experiments, and then Virginia Tech, we came into the picture and we went all the way. We are very applied, so we went outside and we treated outside and do 100% field experiments. Here's the list of all the different chemicals, the ways that we did it as foliar applications, as a drench applications. You have from diamides all the way to, this is a neonic, which is inoterferon, and then you have diamides here, and some of the new chemicals, the 5 and 4Cs as well. So we did all these different treatments, and what happened is we use existing caterpillars in Niagara County to move them to our treated plants. So every week we got to go out and collect. You see here a nice picture of the team, actually now assessing the mortality. So once we collect, we place, from 10 all the way to 20 caterpillars per plant, depending on the population. And then we went back 7 days after and recover even the dead bodies or the ones that survive in order to assess mortality, or in this case, proportion of alive, right? And anything that was on those experimental boxwoods that were treated, we removed, and we did that every week. So it was another Herculean task to collect caterpillars, place it in those boxwoods outside, and then let the environmental conditions work their way, and knowing, because at the end we were interested to understand the residuality of these chemicals. So if I sprayed it once, everything was sprayed once, how long is it going to last killing these caterpillars outside for boxwoods and pots? You can see the plants as well. It was fun, for say the least. It's busy slide. Let me walk you through this. So you have drench and foliar applications. You have 7 days after treatment, the first panel, 21 days after treatment, 35 days after treatment, and 49 days after treatment. That's 7 days, the proportion of dead caterpillars. So the higher the bar, the better. Look at all the chemicals. Almost everything worked. And now we're interested to see what happened in 49 days after treatment. Look at chlorantonilipro, that's a diamide, giving us, on average, 45% mortality, up to close to 50 days. So close to 2 months, these chemicals will be still active and killing specifically, well, chlorantraniliprole, it's a very specific Lepidopteran pest. Lepidopteran, that targets Lepidopteran. So we were pleasantly surprised to see that chlorantraniliprole is one of the best. And actually, this data has been used within the quarantines to inform the quarantines, and if growers need to do treatments, they are suggested to use chlorantraniliprole as one of the best treatments, since our data and previous data also show that chlorantraniliprole is the best performer to kill most of the. Look, there is like chlorantraniliprole has almost 90%, even if you drench it, you have 35% control, like at 7 days. So it outside. So this is remarkable and phenomenal. All right. So I want to leave some time for some questions. We can go back and forth, but I'm getting close to the 45-minute mark. If you want to read more about it, we have two nice publications, VCE publications. So the first one is the overall, so phenology, field observation and things like that. Please, you can Google this, or you can scan the QR code, but this is called the box tree moth in the United States. That was our first publication. You can read it. It's 2 pages. It's very straightforward. It's summarized. I call them the executive summaries. So this is for your disposal. You can learn more about it. There is a little bit of additional details in there as well. So you can read and have this. You can scan the QR code. It's going to take you directly to the PDF, or you can Google it. Box tree moth in the United States, VCE publication, and you're going to get to that publication. You can download it. You can, read it on your leisure, but it will be good that you will have those additional details as well. Now, the second publication is the one that we did last year, and it's a little heavier than the previous one because it has, you can see growing degree days, chemicals, the mating disruption, and again, it's an executive summary of all these different things. There's some additional details presented in its second publication. It's called 2024 Updates for Box Tree Moth. This is the QR code. You can scan that QR code with your phone. It's going to take you to the PDF. If not, again, you can Google it. You can do 2024 Updates for Box Tree Moth, BCE publication. It's going to pop in Google. You can download that and you can read it in your iPad and at any time. Now, box tree moth as a pest is not done yet. It seems like we kind of completed a circle. What else, Alejandro? It seems like, man, you guys have done everything. You got to resolve everything. No, I don't feel that optimistic. Insects are very amazing creatures. And if you are being one of the students when I present about entomology 101 for master gardeners, the insects are the coolest animals on earth. Some of you might hear me saying that. Some of you say, what the hell this guy is talking about? Well, if I go to your place and train the interns, I'm going to make that t-shirt. I keep saying that, hashtag insects are the coolest animals on earth. Hey, what about dogs? What about cats? Okay. I mean, we don't have this discussion here. We're talking about box tree moth. But because the insects are so marvelous and so amazing, there is more things to do. There's more things to understand. One, that it's very, very specific, and it's a request from the growers to say, is there any differences when I use different cultivars for boxwoods? And the answer is all boxwoods get defoliated. So there is not 100% resistance yet that we know. But the intensity of the defoliation is different. Boxwood will have metabolites in their leaf that can be as deterrent for the caterpillars. But keep this in mind. Box tree moth feeds solely in boxwoods. So box tree moth has learned how to, digest those metabolites. But with the new breedings and all these different things, are those metabolites present or absent? Now, here, Lynn also took this beautiful picture when you have winter gem on the left and Green Mountain on the right. And winter gem was demolished. And Green Mountain was still standing, defoliated, but it's still standing. So we have run no choice laboratory ACEs where we were able to see differences among cultivars. There is a beautiful, a great effort at the University of Cincinnati with HRI, the Hort Research Institute. It's funding for us to understand what specific parentals are the ones that actually go more prone to be defoliated, and what are the ones that are quote unquote less palatable. So the caterpillar, remember, as I told Josh, my son, and Emma, my daughter, this is the true berry hungry caterpillar that they're gonna eat. But how much is it gonna eat? It could be expected to be different depending on the cultivars. Stay tuned to something. We'll just submit a paper about this, and this is being very informative. This is the part. So remember, we're trying to build an IPM program. Is a host plants resistant a component of this? And the answer is it could be. Now, we are also interested in releasing beneficials. There are lacewings and trichogramma. They are commercially reared. And you can buy it. You can buy it from Copper, BioBee, beneficial insectaries. There's a lot of these companies offering these beneficials, and you can release those. So now we're interested to see. So here's the lacewing. Actually, this is a real shot. Shout out to David, who is working on this project. And this is in our lab, where this is the lacewing feeding on a box tree moth caterpillar. This is from David's work. And here is the trichogramma, the teeny tiny on an egg mass, using the antenna to recognize those eggs and inserting an egg of themselves in order to kill that egg. So that's kind of like the idea that lacewings will do both, because it's a predator, will do eggs and early instars, and trichogramma will do only the eggs as synergistic. So now we have all these questions about, are they attacking? The answer is, and based on David's data, the answer is yes, they are attacking that, and we knew that. What are the prey and prey interactions? What happens if there is more big box tree moth and a single predator? Now we're studying that part. Now we're going to move to, we're going to move to whole plant assays. And now that we have a quarantine here in Virginia, we will be able to release that in the field. So you see, we take a stepwise approach where we start in the laboratory. We move slowly but steady to understand if this is a feasible approach. So now we're attacking box tree moth from multiple angles. We know phenology. We can predict when it comes. We can use pheromones. We can use not commercially reared beneficials. We can use diamides, in this case, chlorantraniliprole. So we are building the foundations for the integrated pest management for this pest. I don't think we are zero. I think we have some stepping stones to help us managing box tree moth. And this is the ideal situation, because we can support the growers, we can support the homeowners, and provide information and say, hey, we can start with this and see where it takes us. So in summary, so these are my last slides. Box tree moth is expanding. We are the newest member of the Box tree moth club, Virginia. We have a quarantine now established. What does it mean? Is it going to keep moving? Is it going to go through south? If Mark Sutton will say, well, take 81 is going to go south. We don't want that, but hey, we need to be vigilant. And we as a community, master gardeners, everybody at VCE, we have to be vigilant and see if we can detect it early, call it out, and take some action. Now, the adult flight expected, it's in early July, early September, so there's 2 peaks. Larvae will be following that. So now we also learned from 2024 data in Western New York that warmer conditions can shift a little bit the activity, but still we have 2 peaks. Growing degree days will help us predictions, or at least when to expect certain stages of box tree moth being present in the system. And this will help us managing hotspots, right? That's the idea. There is a natural occurring beneficials present in the systems, but not all of them are actually using box tree moth as a prey yet. So there's still what we call naive. Pimpla disparis has been recovered as one of the parasitoids that goes after box tree. which is really encouraging. The area-wide suppression effort showed us a combination of main disruption and Bacillus thuringiensis applications that were successful. We have 60% homeowner participation, and then we were able to show that box tree mold was negatively impacted when we use this area-wide suppression method. And this is very encouraging. This is very encouraging because we have some sort of a path to follow when there is combination of these two that we know that we're going to be managing box tree mold. Now, we tested several effective insecticides from the lab with IR4 and USDA APHIS PPQ to Virginia Tech in the field, showing that chlorantraniliprole, in this case, is called a aceleprine. That's the trade name. Chlorantraniliprole is one of the best molecules that are, going to keep in check box tree mold up to 49 days, which is amazing. Upcoming research, I'll show it to you, cultivar preference, releasing biological control agents that are commercially reared. And we are so thankful that there is a strong relationship with the growers, the boxwood growers across the nation. They are being supportive, and all of this has been possible because they were interested, they bite into this, and they were able to guide us and be vocal about the needs of the industry. So that resulted in a compliance agreement, which help us keep commerce and trade safely in affected areas. So growers are not losing thousands of dollars. On the contrary, if they sign it into the compliance agreement and they follow the steps that our research has shown, they will be successfully able to mitigate the risk of moving box tree mold from outside the quarantine. So that compliance agreement is in place. It's managed by every state, and it's a beautiful document where all this research has been compiled, and now we have ways to aid the growers avoiding huge and significant losses. Because if you are in the quarantine, you cannot sell. Just picture about how much money you will be losing. And that's not happening because we were ahead of the game. We went and chased down the true berry hungry caterpillar. We learned before even got established, like in a second state, and then we shared that information, and then the leadership of USDA APHIS PPQ also was fundamental and very important in order to mainstream this compliance agreement that now we can use. With that, yes, that's a tombstone. We went to a lot of cemeteries, believe it or not, to look for box tree mold. So if you have any questions, that's my email address, but if you can Google me and you will find my information, but that's my email. Again, it might take me some time to get back to you, but if I could be in any help, I will be happy to do that. Grace, for me, that's all I have.
Awesome. Thank you, Alejandro. This is fantastic. We have some questions in the chat. I've answered some to the best of my ability, but there are a few that I'd like to get your your take on. Box tree moth eats Buxus species of, but anything else right now that we know of? Okay.
There was old literature that said unanimous. There was a different plant type, but it was corroborated as not. So right now it's solely boxwood. Boxers.
Okay.
Yes.
Okay. I put the link to the VDAX press release in the chat. And I saw you shared the VCE publications. I would direct people to those for more information too. There's a question, and this is something I didn't know. Sticky traps, are sticky traps banned in areas of Virginia that have rusty patch bumblebee, the endangered bumblebee? I mean, if it is, I don't remember it being enforced. Based on where I've seen sticky traps go out, I think that's hard to enforce, but I didn't know that was a thing. So
yeah, so everything that you see for sticky cards work went in Western New York. We haven't done any sticky card work in there, but yes, there is a component about being conscious if there is an endangered species, how we can do that. Well, I'm sorry that I skipped that, but we also did visual scouting. And when we do the visual scouting, you can count spiders and things. So there are multiple ways. We just wanted to pair as much information as we could, and sticky cards are the one of the best ways to do that. But yeah, something like that is it. And thank you for whoever brought it up. But yes, it will be something to consider.
Yeah, so one of the other questions is some chemical control questions. Um, and some you covered some natural enemy questions really well. But one of the questions is, does that this is spotted lanternfly. Does the spotted lanternfly, since it's been here for a while, things are getting used to eating it, right? And knowing what it is. Does that predator prey graph look really different for spotted lanternfly than it does for box tree moths just because it's been here longer? Like, how long does it take the ecosystem to adjust to the point where it might start addressing some of the box tree moth problem?
So based on our data, I'm sorry that I don't have the data for spotted lanternfly.
That's okay.
And I don't want to give numbers, but some based on our data, 3 years in a row, we still saw that the beneficials were kind of like hesitant and not learning how to use those things. Some of them, like Pimpla disparis, was able to, we found something new, right? So it will take time. It will take more than 4 or 5 years for the entire system to recognize that it's a new kid on the block, and then like, all right, we got to do something about it, right? But the beauty is that the first ones are going to do that, and we saw this. I have some pictures, but there's spiders and some dermaptera. So there's some predators that will eat the box tree moth, but consistently or in a pattern that we can observe, unfortunately, within 4 years, we didn't see any. So it will take at least 4 or more for the entire system to be consistent and say, hey, this is the present, and the predators will be there to eat box tree.
Yeah. And even then it probably won't be enough pressure to address, an actual infestation, especially for those of you on the call that have commercial responsibilities, especially
Yeah.
for good commercial grower, it just won't do enough.
Yep.
So what is that risk of chemical treatment adversely affecting other Lepidoptera species that are native to the region? And some like off-target questions like that. It's really effective and it's good that it's specialized, but is there anything else that's visiting boxwoods that we should think about before we apply that?
No, I used to say the box tree moth was the only Lepidopteran present chewing on boxwoods. And I was so failing that. It's called a trash bug. It's a tortricid. So it's a leaf roller that it could be also present defoliating boxwood. So please keep in mind that not necessarily a defoliation might mean that you have box tree moth. So we really need this specimen. Because in the past, when I started working with box tree moth, I said, oh, the only caterpillar you're going to find is box tree moth. And somebody's like, oh, that's not accurate. What do you mean? I haven't found anything. Yeah, because you haven't found it, doesn't. And then we would keep looking. So to round that answer, there are very few lepidopterans, or not say two only, that feeds on boxwood. So the non-target effect might be mitigated because they're so specialized and there's no generalist leps that are feeding on treated boxwood. So in that sense, I personally believe that it's a safeguard and it's good. It's a positive thing that not many caterpillars are feeding on boxwood. They're going to pick up those diamides that have that visibility. So in that concern, I will be, well, 2 or maybe 3, right? But in this case, it's an entire industry that needs to be protected. So how can we wade in? I think we need to look into more alternatives. I think that I agree. Bacillus thuringiensis, for example, which is not long lasting and it's It's one knockdown and you good. How can we protect that with UV adjuvants and all the different things? Those are the next things that are coming. So stay tuned because we want to cover that part as well. And I'm so glad that you guys are asking those because those are very relevant questions.
We have a few questions about birds and bird predation. Birds eat a lot of caterpillars in general, in the ecosystem. And so there's some questions about if we use chemical control on the caterpillars and the birds eat dead caterpillars, are we concerned about the birds? And then also like, is that one of the natural predators in the native range for box tree moth? Is that something that eats box tree moth in Asia?
I'm getting more and more questions about this. I need to apologize to everybody in the audience. I'm not very well versed on bird box tree mod interaction. I should, and I'm going to be diligent on that. But based on my limited observations, the interactions were very limited. And here's some of the reasons that I understood back then is that the caterpillars are not very well exposed. They move through the canopy and they like to start outside and then move. So, and they blend very well with the boxwood canopy. And the boxwood canopy is very dense. So I don't know how many birds are going to be getting into and then exploding unless you have a huge infestation. The caterpillars are hanging like Christmas decoration, which I've seen those. So that's the extreme. Now, the moth are flying, there might be some birds that are doing that. But those will be the ones that survive and have less chemicals. So in feeding on adults, I think it's less riskier than feeding on the caterpillars, which can be contaminated. I'm going to stop myself there because I don't want to say more things that I don't really know. But just keep in mind that the architecture of boxwood is not prone to inviting birds. And unless all the, the deciduous tree and all the shrubs there, why, they're open and birds can see. And then on top, they blend really well. Like you have to be really used to looking at the box tree moth caterpillars to know, that one of the things is the fecal pellets. Another thing is the webbing, because if you look for caterpillars, it is likely you're going to miss it. And like it's like they are really, man, they like to go places and they're really mobile within the canopy. So I think they have the advance in terms of bird predation, but please don't quote me on that. I will keep reading about it. But I want everyone to understand where this rationale is coming from based on field observations of it.
Yeah. Okay, one last question, just because I missed it and I'm not sure. How many larval instars are there? And is there enough, like for us observing, is there enough of a difference that we need to know that?
Well, so it was documented up to the sixth instar, right? If it's expected, the fifth or sixth could be the ones, and you will be able to see it after the third. So third, it's close to an inch, and I can find some pictures and send you Grace about that if you can remind me about it. But there is a size component of those, and the larger the caterpillar, the easier you can get it, right? In an idea. So, but unfortunately, the larger is the more that they're munching, and the more damage you're gonna have. So there is a counterbalance between those. Ideally, we want to see the teeny tiny caterpillars, but they are so difficult. I think, not I think, if I remember correctly, 2 seasons, 2022 and 2023, I think we found only what, 10 egg masses across the entire two. Like looking for those egg masses, it was. So now picture the neonate that's come kind of like that teeny tiny. So it is expected you're going to miss those things. But then hopefully you can see a third instar, which is closer to an inch or, and then from there, the sooner you can get them, the better. Because larger the caterpillar is, more difficult to control. By the way.
Okay, thank you. I want to make sure we're respectful of Dr. Del-Pozo's time. He's very busy. Um, we usually post some things in the show notes afterwards, so I'll link the VCE publications and other things in the show notes for this, as well as other information. If you guys have questions, it is okay to reach out to Dr. Del-Pozo via email. If you think you found box tree moth in your locality, it is a good idea to loop in your Virginia Cooperative Extension
Yes,
agent.
please. Yes.
Please do.
Please do. Your county
Please do.
agent will be instrumental. Even though we are required to report it to the Department of Agriculture, I beg everyone, keep Virginia Cooperative Extension within the loop. In this case, Eric Day has retired, but stay tuned. There's a new person who's coming. So it will be also ideal to keep informed the insect ID clinic. So please, the more that we know about it, and then in parallel, VDAC will be informed. Sorry, Grace, that I interrupted you, but I want to make sure that this is also a take-home message that we can provide the support. The Virginia Department of Agriculture will provide the support, but they are the authority, and they need to know when there is report.
Alejandro, real quick clarifying question on that. I know when at a point with spotted lanternfly, once they went under the quarantine, they didn't want to know any more infestations in the quarantine zone.
I haven't heard anything,
okay.
But to be honest, Ed, I think every report of box tree moth since we're in the beginning will be taken in.
Okay.
I remember when I met Virginia Department of Agriculture in Winchester last year, when first detected, I met with some of them, and they're going to be investigating, even though it's within the quarantine. So I haven't heard anything different. But if I do, I will let Grace know, and Grace can spurs that information to all of us. But as I know, anything anywhere that we find got to be reported. But please bring along the county agent, because the county agent will talk to me, to the department, and then we all gonna be able to help. That's kind of like the idea.
Yep, and I want to remind our extension master gardeners, look on your own property or on public property. It is not okay for you to go to a commercial nursery and be scouting around for this. Trust me, they are already looking. But your agent should be looped in, because your agent has a good idea of where it's been seen before, and sometimes detections are reported before they're broadcast by VDACs or announced, and so they'll probably know, kind of the area that it's been in. Without necessarily that being public information yet. Also, nobody wants it's like being sick, right? Nobody wants everybody else to know that they're sick. Nobody wants everybody else to know that they've got box tree moth on their property. It's not glamorous. So just be respectful if you do find it, to just, report that to the proper authorities and give people good information, be good stewards of everybody's privacy with that. So with that, big thanks to Alejandro for a fantastic, wonderful, informative presentation. I will post some things in the show notes afterwards for some more information. See if that, if maybe like a week or so before that comes up, maybe sooner if I have my act together. And if you've got more questions, feel free to reach out to Alejandro or to me. If you're looking for a resource, I'm more than happy to help. Okay, thanks everybody for joining.
Thank you.
Thank you, everyone.